So in scenario 4, we have the pre-evacuation times according to the location and the exit usage that was apparent during the evacuation. And in the final two scenarios, I'll be looking at the, what might happen if the procedures were changed. If there was some manipulation of the procedures so that people were able to use their nearest exits, and then if the procedure was missing altogether and people used the exits according to their common circulation knowledge. And here we have a graphical representation of what this actually means. In scenario 1, we have people responding instantly and moving to their nearest exit. So you get almost like a line drawn down the centre of this room and people being fairly evenly and uniformly attracted to their nearest exit. In the more sophisticated representation, where people have been, had a pre-evacuation time distribution applied to them, the first thing you notice is that people respond at different times, and also that people respond and travel slightly more. The usage of the exit isn't purely based on proximity, but it's according to their awareness and knowledge of the exit. And of course, this more accurately represents, or the process more accurately represents what might be expected in a real evacuation. So here we have the results, and what was most pleasing here was that as the information that was included in the model became more accurate with the original trial, so the results and the processes demonstrated within the model also approximated those in the original trial. So when we have an instant response time, the evacuation times generated are relatively low, and as we incorporate the more accurate pre-evacuation times, they converge towards that time generated. So that the final result in scenario 4 was 309 seconds, which is a difference of 1.3% with that generated with the original trial. Now, obviously, the original trial represents a single data point, and we generate a number of data points, so that has to be borne in mind, but it's still a satisfactory result. And more pleasing was the fact that the final distribution included the evacuation trial time, and that's probably more important than the actual percentage difference, I think. So here we have the evolution of the simulation results, so that here we have the curves representing the arrivals of individual people and the time it took them to actually reach an exit. So for the first two scenarios where the individuals were assumed to respond instantly, the curves are too steep, as you would expect, because people arriving at the final exit after responding immediately. And also the arrival times tends to be dependent upon congestion at the final exit, and this was not noted during the original trial. The final two scenarios, where we have an approximation of the pre-evacuation times during the trial and the exit usage, far more closely represents the original trial data, and you can see that it falls between scenario 3 and 4. So this gives an indication that not only do we get the final endpoint of the evacuation trial, but we approximately get the processes that are involved. And we can only say that, of course, because we have some qualitative analysis as well, and which will follow in the next few slides. Again, this is just refining it down. So we have here a direct comparison between scenario 4 and the times observed during the original trial. And again, you can see it's quite a good approximation. Now here we have, again, the frequency distribution produced during the simulation. So we have the pre-evacuation times and the overall evacuation times, and we can compare this with the data collected. Now, as you'd expect, the pre-evacuation time frequency distribution approximates this quite closely, whereas the evacuation time produced is slightly different. This is due to the fact that we couldn't necessarily tie the exit usage of each individual with the pre-evacuation times. That was due to omissions in the closed-circuit TV. And in effect, that was quite an unrealistic thing to actually do within a model, because you very rarely have that type of data. Here we're looking at the data according to the exit usage and the time of arrival. And as you can see, if you concentrate on scenario 4 here, although there's a lot of data in this table, you can sort of see that the evacuation times produced are approximately the same. There is some variation, and this is largely due to the fact that the number of people using each of the exits, shown here in black, is also approximately the same. Where there is a discrepancy is where there are relatively few people using each of the exits, and this is again due to the fact that the exit usage and the pre-evacuation times wasn't tied together. So it wasn't coupled. So, for instance, somebody using an exit may have been some distance away, or may have responded far more extensively. Now here we have The time spent by each of the individuals during the simulations in congestion. Now, we knew from the questionnaires that were conducted that people actually didn't experience a great deal of congestion, and the congestion that was experienced tended to be on the staircases or just leaving their initial location. Now, in the first two slides here, first two graphs, you can see there's a general trend for the congestion to rise during the simulation. This was indicative of the fact that people were experiencing congestion at the final exit point. So this was obviously different from the conditions that were evident during the original trial. In the scenarios where we actually represented the pre-evacuation times more accurately, the congestion shows very little obvious trend, with people's congestion varying throughout the simulation, which was more similar, approximated more closely the conditions that were reported to us by the evacuees. Now you can look at this, the proportion of the time spent by each of the individuals during each of the scenarios. And in the first two scenarios, a vast amount of their time, approaching 40% of their time, was spent actually in congestion. Again, this differed quite significantly from the conditions reported to us during the questionnaire phase. In scenarios 3 and 4, where the response time formed a far more important aspect of the overall evacuation time, and the congestion experience was relatively small. And it actually appeared slightly more extensively in scenario 4 because of the clustered response of the people according to their location. Here we see again another qualitative comparison that we had through some of the footage that was gained through people's movement on staircases. We can see that there's a relatively staggered usage of the staircase, and this was approximated by the Exodus model. We have this here, a two-dimensional representation of exactly the same staircase and the same location at approximately the same time in the simulation. So again, this enabled us to compare the qualitative aspects of the evacuation, giving us confidence in the quantitative results produced. Okay, this is the first of the what I term the investigative scenarios. In this scenario, for A, I was looking at whether it was what might happen if procedural changes were made and a more complex procedure was used. That is, signage or additional staff was put in place so that people use their nearest exit rather than using the exits that they did during the original trial. And you can see there's a modest improvement in the overall evacuation time. And that the congestion experience was again comparable to the congestion experience during the original, during both our scenario 4 and the original trial. In scenario 4B, where we assume that people use the structure according to their circulation understanding of the structure, their normal knowledge, effectively no procedure being applied, we can see there's actually a modest increase in the overall evacuation time. Now this might not actually look like it's a very significant result, but you'll see that actually far more of the person's time was spent in congestion, and this might have an important impact if, for instance, there was a real hazard within the structure. Again, we can look at this in more detail. With here we've got the staircase usage and the usage of the final exits. During scenario 4A, where people use their nearest exit, we see a more even distribution amongst the staircases. Again, because of the relatively light usage on the staircases in the original trial, this didn't have a huge impact on the results produced. When people use use the structure according to their general understanding, we see a far more heavy usage of 2 staircases in particular, and also we can compare again the usage of the exits. Obviously, when there's only one exit used, there's a far higher load on a single exit in the final scenario. Where we've employed the new procedure, we can see that actually, given that the exits were originally used in a fairly distributed and even pattern in the first place, that again hasn't necessarily led to an improvement in the final results produced. So what can we conclude from that? From looking at the changes in the procedure, actually employing a more complex procedure, there was no appreciable advantage produced. And this might be particularly useful if you were managing the procedures within a structure and actually were testing new procedures without having to actually go through being able to test the procedure before you actually employ it. In scenario 4B, where we assume people use the structure according to their general circulation knowledge, we see actually quite a significant amount of changes in the congestion experienced. Now this effectively is saying if the procedure was entirely removed, what would be the consequences? Well, the consequences would be people would be stuck in congestion far more. And as I said previously, this might have an important outcome if there was smoke in corridors or if there was a real fire scenario.